Today we're going to be focusing on some parallel and perpendicular lines. We are going to be using the point-slope form equation, so you might need to remember that as well. So, parallel lines. We all know about parallel lines. They are lines that do not intersect. But what's important when it comes to this lesson? Parallel lines have the same slope. Parallel lines have the same slope. That is extremely important. That is one of the main points. So, let's look at this line right here. If we write this equation of this line, the equation would be y is equal to 1x with the slope of 1, because we rise from the point, rise 1, run 1. So it's 1 over 1, which is just 1. Now, let's look at the slope of the blue line. For the blue line, we would have y is equal to, figure out the slope from any point, rise 1, run 1. So that's 1 over 1, which is the same as 1x. Crosses on the y-axis at -4. So this would be -4. Now let's compare these two equations. Remember, parallel lines, same slope. Let's look at the slope. The slope of the first one is 1. The slope of the second one is 1. Thus, they are parallel. It is extremely important that you realize that parallel lines have the exact same slope. So now we have to write an equation in slope-intercept form that goes through the point -3, 5 and is parallel to y equals 2x minus 4. Let's look at the key points. We need a point. It needs to be parallel to this line. So we have two steps for you. Number 1, find the slope of the given line. So we have our given line right here. Y is equal to 2x minus 4. So what is our slope of this line? Remember, y equals mx plus b, where m is the slope. So the slope in this is 2. So m is going to equal 2. Step 2. Use the point-slope equation to convert to slope-intercept form. Remember, from the previous lesson, what is the point-slope equation? It's y minus y1 is equal to m times x minus x1, where m is the slope, y1 and x1 are the points in a graph. For example, we got -3, 5. So, let's input some numbers. So if we have y minus, what's our y1? y1 is 5. Y minus 5 is equal to, our slope is 2, in parentheses x, minus our x1 is -3. So there we go. Now, we just have to solve it into slope-intercept form. So I'm going to rewrite this a little bit. So y is minus 5 is equal to 2x. And this is going to be, I'm just going to change this to +3, because if you're adding or subtracting a negative, it's basically like you're adding a positive. Oops, sorry about that. Should be a 3. Now, distributive property, y minus 5 is equal to 2x plus 6. Now I need to move this 5 over to the right, where I will add 5 to both sides. So y is equal to 2x plus 11. So I have a new equation. Y is equal to 2x plus 11. That is parallel to this equation up here. Y is equal to 2x minus 4. Remember, parallel lines must have the same slope. So we have 2. We have 2. And so this, y equals 2x plus 11, is our final answer. I really need you to write down these steps because this is very important when you're trying to solve a parallel line. So we talked a little bit about parallel lines. Now we're going to be moving into perpendicular lines. So what are perpendicular lines? They are lines that intersect at right angles. By that I mean that they create 90-degree angles. What's important? The slope of the line of perpendicular lines are opposite reciprocals. Opposite reciprocals is important. By that, for example, if I give you 2/5, the opposite reciprocal, the reciprocal of 2/5 is 5/2. That's the reciprocal, and the opposite of it, since this is a positive 2/5, it's a negative 2/5. That would be the opposite reciprocal. If I say the number 4, the opposite reciprocal, or the reciprocal of this is 1/4. Opposite of it makes it a negative. If we have another one just real quick, if we do negative 5/7, the opposite of that is positive, and it must be, the reciprocal of that is 7/5. So, opposite reciprocal for perpendicular lines is extremely important. Thus, it is another main point. Alright, so now we have a graph, and I want to know, are these perpendicular lines? We got our red line, we got our blue line. So remember, if they're perpendicular lines, we need to figure out if the slopes are opposite reciprocals. It sort of looks like it makes a 90-degree angle, but I really just want to make sure. So we have 2 steps. First step, find the slope of both lines. So it doesn't really look like it gives us any points, but we can make our own points. So we have a point here, and it looks like we have a point here. Now, remember, what is slope? Slope is rise over run. So let's start at this point. To go from this point down to this point, looks like we have to rise a -2, and we have to run a +1. So the slope would be -2 over 1. Now in the blue one, looks like we have a point here, and we have a point right here as well. So again, we have to find the slope of the blue one. So let's start here at this point. You can really choose either point. That's perfectly fine. So when you rise, looks like you're rising 1. So you rise 1, and you run a +2 to the right. So those are the slopes of these 2 lines. Step 2. Are the slopes opposite reciprocals? Well, this one's a negative, this one's a positive, so the opposite part, yes. Are they reciprocals? We have 2 over 1. Reciprocal is basically where you flip the numerator and the denominator. This is 1 over 2. So yes. So, are these perpendicular lines? Yes, they are, based on the slopes being opposite reciprocals. I highly recommend writing down these two steps for this. So we have an example here. We need to write an equation in slope-intercept form that goes through the point -3, 2 and is perpendicular to y is equal to -2x plus 4. Underline the important information. We need to go through this point. It needs to be perpendicular. It needs to be perpendicular to y equals -2x plus 4. Now we have a couple steps, sort of like parallel, but there's one big important step. Step 1, find the opposite reciprocal of the slope of the given line. So, here is the slope of the given line. It's a -2. Now, I need the opposite reciprocal of the slope of the given line. So the the reciprocal of -2 is 1/2, and the opposite of the negative is a positive. So our opposite reciprocal is 1/2. Now, step 2. Use the point-slope equation to convert to slope-intercept form. So slope-intercept form is y minus y1 is equal to m times x minus x1. So we have y minus, our y1 is a -2, is equal to m. Remember, the slope that we're using is 1/2 times x minus, our x1 is -3. Alright, I'm just going to clean this up because remember, if you're subtracting a negative, it's basically like you're adding. So I'm going to clean this up where y plus 2 is equal to 1/2 times x plus 3. Now all we have to do is the distributive property. So we have y plus 2 is equal to 1/2 x plus 1 and 1/2. When you multiply 1/2 times 3, you get 1 and 1/2. So now we just need to get we need to get y by itself. So we need to move this plus 2 over to the right by doing that. Subtract 2. So y is equal to 1/2 x, and if we have a positive 1/2 and we're subtracting 2 from it, we will get minus 1/2. So our equation that is perpendicular to y is equal to -2x plus 4 is y is equal to 1/2 x minus 1/2. So remember, the slopes must be the opposite reciprocal. So the opposite reciprocal of -2 is 1/2. Thus, y is equal to 1/2 x minus 1/2. So now we have a couple of lines, and I need to see if any of these lines are perpendicular or parallel to each other. I'm going to do the first 3, and you're going to then pause the video and do the second 3. So the way that you're going to do this, basically, find the slope. When you do that, remember, if it's perpendicular, the slopes are going to be opposite reciprocals, or if they're parallel, they're going to be the same slope. So let's basically just find the slope. Slope of this first one is 1/2. the slope of the second one, remember I need y by itself, so I'm going to have to divide by 3. I'm going to do that a little bit down here. So if we have 3y is equal to x, we're going to have to divide by 3. So y is going to be 1/3 x. So the slope for the second one is going to be 1/3. Slope for the third one is going to be -1/2. So are any of these perpendicular? Remember, it must be opposite reciprocals. So these are opposite, but they're not reciprocals. And these aren't the same slope. Parallel, these are the same slope, but they're not the same sign. So the answer would be neither parallel or perpendicular. So what I want you to do, pause the video, try these 3 off to the side, unpause the video when you're ready to see what I've done. Okay, so this first one, find the slope. Slope of the first one is -2. Slope of the second one, if we have 2y is equal to x, got to get y by itself, so divide by 2. So y is going to equal to 1/2 x. So the slope in this case is 1/2. Now we have this third one. It's going to take a little bit of work. So if we have 4y is equal to 2x plus 4, you have to divide everything by 4. So y is equal to 1/2 x plus 1. The reason why I got 1/2 is basically just because I simplified it. I divided both the numerator and the denominator by 2. So we got 1/2. So the slope is 1/2. So let's look at this. Are any of these lines perpendicular? So perpendicular, do they have opposite reciprocals? So we have a -2, and then we have, so the reciprocal of -2 is 1/2, and the opposite part would be a positive. So it looks like y is equal to -2x is perpendicular to both of these. So these are perpendicular. So both of these are perpendicular, and this one's perpendicular too. Now, are any of these parallel? By that, are there any similar slopes? Well, we got 1/2 and 1/2. In that case, these are parallel. So remember, basically all we got to do, find the slopes, then check to see if they're perpendicular or parallel. So it's time for review. I know if the lines are perpendicular, the slopes are going to be opposite reciprocals. If the lines are parallel, we know that the slopes will be the same. I know this is a lot of notes and it's a lot to take in, but take your time with this. Let me know if you have any questions.